All right, this is our lesson on graphing. So, wanting to point out importance of graphing in a science classroom, right? The idea of when you have large amounts of data and it's created into tables and you have to read these spreadsheets with all of these different data values, it becomes quite confusing. Many people find it much easier to be able to look at that information in some sort of graph, right? Line graph or a bar graph, or sometimes it could be in a pie graph, all right? Some sort of visual representation to be able to display your data and observations, all right? So the idea is, when you want a great story, do you like to read a book, right? Do you want to have pictures? Would you rather have somebody else read to you, or maybe you'd rather have a movie? Graphing works very much the same way, all right? It's really about preference and creating another way to display that scientific data. And for many people, that visual representation, right, is more beneficial to their understanding. So it's a visual representation of the data. So they can write the data in a report, they can put it in a table, or they can create a graph, right? All these different ways to display that data, all right? Which one would you particularly prefer, all right? It'd be great if the information was available in all forms, so anyone could be able to understand it. Like, you could read about it, you could look at the table, or you could picture it. That's what a lab report is, all right? A lab report is a way, all right, for you to create the table, to organize your data, generate the graph based on the data, and then write in your conclusion about the results of that data. So it's a way for you to kind of combine all these different forms of conveying your information, your data results, your lab results. So how exactly are you supposed to create this graph, and what kind of graph are you supposed to create? All right. Like I have told you guys before, if you feel like you've mastered something, always move on. So if this is not something that's relevant to you, please move ahead. So our types of graphs, we've got line graphs. And it's important for us to recognize that a line graph deals with changes over time. All right? A bar graph is usually for comparing quantities, how much of something or how many of something there are. And then a pie graph is used to show parts of a whole. All right? So what that really is referring to is a line graph is when we're talking about time. We're talking about years, days, weeks, seconds, months, whatever, minutes, all right? A bar graph is really talking about how much or how many there are when you want to use a bar graph. And a pie chart is talking about a percent or a fraction, a portion of it. So parts of a good graph, you always want to make sure that you include your title. It's also important that when you create your title, center it, underline it, make it apparent that you have this title, all right? It shouldn't be a sentence, but it needs to be pretty detailed. So for example, calories burned. That's not really very specific. Calories burned by cows, calories burned by people, right? Calories burned in a year, calories burned in an hour, all right? You got to be pretty specific. Calories burned over time, or perhaps calories burned over time while exercising, all right? Plant growth. Plant growth. What's the plant growth based on? Sunlight? Is it based on temperature? Is it based on water? All right? Be specific, all right, in your title. So, for example, what we have here, a title for a graph, scores by team per season. Right? This graph should look relatively familiar to you. Scores by team per season. Is that really enough for us? Right? Or are we looking for more? Including the team name might make it more descriptive. So, scores by 3 different basketball teams. all right? What sport are we looking at, all right? Scores by basketball teams over 4 seasons. You need to find some descriptions here. Our axes, the 2 lines that box in your graph on a bar or a line graph, and it's how you plot your data accurately. So you need to label those axes and include measurements, right? Those measurement units. So you should know that we have the y and the x-axis. We want a label, and in parentheses you usually want units. And over here we want a label, and in parentheses you usually want units. So that x-axis, the bottom axis, right, is how we represent the independent variable, right? Remember, independent variable is that one little change for the experiment. That one little tweak that you're making to one group to make it different, all right? So if you're recording the plant growth and varying temperatures, the one little tweak that you're going to make is going to be temperature. You're not going to change the plants. You're not going to change their growth. You can't do anything about it. You're going to tweak the temperature, and as a result, you're hoping that the growth will change. The y-axis is where you're going to place your dependent variable, all right? The change based on what you tweaked. So like the plant growth, all right? If on our x-axis we are plotting temperature, don't forget we need to include units, so we're going to talk about degrees Fahrenheit, all right? So we're going to talk about degrees Fahrenheit. While on the y-axis, we're going to talk about the dependent variable, what should occur, what should change because of the temperature. And that should be the plant growth. The plant growth is what we're expecting to be different because we changed the temperature. And plant growth, let's say we're measuring plant growth in inches. Right? So like I said, making sure that you include units on the axes. So, making sure you include units on the axes is crucial, but it's also important for you to make sure that you include increments of measurement, right? So you don't need to place it on every single marker on the graph paper, but make sure that you pick a value that you're going to increase by. So the other thing is that they should all represent the same amount. What do I mean by that, representing the same amount? Well, what I'm talking about specifically is making sure that when you have your graph and you've given it a title, plant growth in varying temperatures, and we put plant growth on this side, and like I said, we're doing it in inches, and we've done temperature on this side in degrees Fahrenheit. You need to pick your increments. So let's say we say 1, 2, 3, 4, 5, 6, 7, 8. We don't need to label every single one of these. We just need to make sure, sorry, that's 2. We just need to make sure that it's clear what the value is increasing by. Likewise, when you use temperature, you don't get to decide that this is going to be 5, 10, 15. And then you realize as you're counting on that, oh shoot, I'm not going to have enough space, so I'm going to run out and not be able to reach my values. 30, 45, 6, what is this? We went from having a value of 5 degrees Fahrenheit to suddenly we're valued at 15 degrees Fahrenheit. So those increasing increments need to be consistent, and it's important for you to make sure that you space them out appropriately. So, as we see here, we've got increments of 2, right? We've got games 1. We don't need anything in our unit because all we're doing is counting, all right? But we're missing something, right? We're missing that x-axis label. Years. Or maybe perhaps it's seasons, I'm not sure, but we're missing that label to be able to be sure of what it is we're looking at. The next thing is that once you've got everything set up, it's starting to plot your data, right? And using data points. A line for our single data recording versus a bar graph. You still need to identify where you're going to mark those specific points on the line or the tops of the bar, and you need to properly plot those data points so that your data is accurate. So counting how many data points we have 1, 2, 3, 4, 5 different data points in this particular graph. A legend or a key. Many graphs need legends or keys in order to understand when there's multiple sets of data. So it's important, like for example, in this pie graph, all of these different colors mean absolutely nothing without our legend, without our key to point out exactly what these slices of the pie are for. Some of the other things to keep in mind is in a line graph not to curve your lines unless you're instructed to do so. A line graph should be straight lines. Connecting the points with a ruler, not freehand, making it nice and neat. Double checking your data for accuracy once you've plotted it. If you're using graph paper, make sure you use your space, right? Don't have a piece of paper and make your graph this little teeny tiny corner. What about all of this unused space that could have spread your graph out further so that people would have been able to easily read it, right? So use that space that's provided to you, right? Now, you can go back and you can practice. You can look at your graphing and data analysis worksheet and the answers that have been provided. If you have any questions about graphing, please feel free to see me.